This podcast will introduce bonding. So atoms bond so that they can have 8 valence electrons, and these are the S&P electrons in the highest energy level. There's 3 types of bonding that we're going to talk about. Ionic, which is a metal plus a nonmetal. Covalent, which is a nonmetal with another nonmetal. And then metallic, which we'll briefly talk about, where you only have metals present. Here's some diagrams showing this. Ionic is electron transfer. Covalent is when 2 nonmetals share electrons. And then metallic is only metals present. And electrons pool, or electron called an electron C, which we'll talk about later. So we have written electron dot structures already, which are shown here. Here's a summary of all the main group electron dot structures for group 1A and 2A, 3A, etc. And the dots around the edges show the number of valence electrons. So the Lewis dot structure helps tell about an element's predicted bonding behavior. Metals only have a few valence electrons, so they are going to lose them to form cations, which form ionic bonds. Nonmetals usually have almost filled valence electrons. They're up here in the corner, so they are almost filled, so they are going to want to gain electrons to form anions if they're with a metal, and to share them if they're with another nonmetal. So the octet rule says that an atom is going to want to have 8 valence electrons, which are filled S&P orbitals, in order to be stable. And keep in mind that that is 2 electrons for hydrogen, because hydrogen only has room for 2. So for hydrogen, an octet, even though it's not 8, 2 fills up its valence shell.